The last of our practice questions now is an example of Newton's third law and Newton's second law. So part A, an apple has a mass of 0.255 kilograms. What is the weight of the apple on Earth? So the weight of the apple, so now this is a force on the apple by the Earth. It's really important to identify the agents of the forces. So it's on the apple and it's the earth that makes the force. We know that weight forces are m times g, so it's the mass of the apple times g. 0.255 kilograms times 9.81 meters per second squared. That's an easy calculation. The weight of the apple is equal to 2.50 newtons, and the direction of that force is down towards the center of the earth. Okay, so consider Newton's third law. This is really interesting because it's not an uncommon exam question to ask what is the reaction force to the weight. The most common answer we get to that is the normal force, and that's actually not correct. If we think about Newton's third law, let's remember how that works. If I push on the table pushes on me. If you push your friend pushes on you. You see how that works? So for the weight of the apple, it's on the apple by the earth. The reaction force, so Newton's third law says for every force there's an equal and opposite force, or reaction force. So the reaction force is the force on the earth by the apple. So Newton's third law, so weight of the apple, the reaction force on the earth by the apple. It has the same magnitude, 2.50 newtons, and it has the opposite direction. That's how Newton's third law works. For every force, 1 on 2, there's an equal and opposite force, 2 on 1. That's how you get those pairs of forces. So let's just do a quickie free body diagram. There's our apple. There's the weight by the earth on the apple. Here's the earth. That's really big. There's an equal and opposite force on the earth by the apple. So we'll call that the weight of the earth, or WE. So this one is on the apple, this one is on the earth. So the weight, or the force, on the earth by the apple equals 2.50 newtons towards the apple. So that's how these reaction forces work. You basically just switch these two words to get what the reaction force is. What is the resulting acceleration? Well, we know the sum of the forces in the y direction is going to be the mass of the earth times the acceleration in the y direction of the earth. The force is the weight on the earth, the 2.5 newtons, equals mass of the earth times the acceleration. The acceleration is going to be the force on the earth divided by the mass of the earth. That's a number we can just look up in the book. It's pretty big. That gives us an acceleration of 4.19 times 10 to the minus 25 meters per second squared, and in this direction that points straight up. Okay, so that's pretty interesting. Just to take these reaction forces a little bit further, so I said a moment ago that people will comment that the reaction force to the weight is the normal force and that that wasn't true. So let's think about what is the reaction force to a normal force. If I have a box sitting on the table, then the normal force, what is the normal force? Table on box. The reaction force to the table pushing up on the box is that the box pushes down on the table. Okay? The force is exactly the same size and in the opposite direction. Okay, so reaction forces is always 1 on 2. The reaction force is 2 on 1. Equal magnitude, opposite direction. We'll talk about this more in the next chapter.